Hi everybody, welcome to your first video lesson for Unit 4 Statistics. And today, for this video lesson, we're going to focus on displaying data. Now, as you can already see from the first couple of things you've done for this unit, it is very heavy on definitions, but it is typically a mark boosting unit. A lot of the stuff isn't really that bad. And many of the things that we're going to cover, including today, you did probably grade 6, 7, and 8. And if you have any different colors with you at home, maybe pause this, grab some pencil crayons, grab some markers, grab some highlighters, some different colors, as we're going to be making some graphs. First, we're going to start out with some definitions. So we have three different types of data we're going to look at. Categorical data, which is also known as qualitative. And this is data that are types rather than numbers. So for example, favorite color, favorite type of snack food, the color of your eyes. Those are all categories, those are all types of things. Those have nothing to do with actually having quantitative data. Your next definition, continuous data. This is quantitative, which means that it has numbers. So qualitative, no numbers. Quantitative, definitely has numbers. And continuous data can have any numerical value within a finite or infinite interval. Usually this type of data is measured. An example would be like the height of students in the class. So how tall are you? That's a measured value. I can measure the height in centimeters. I can measure it in feet. Doesn't really matter. We can also say, how old are you? That's a measured value. I can measure you in years. I can measure you in months, years plus days, anything like that. So we have a numerical value as one of our answers. And discrete data is also quantitative. And we're going to talk about that in a second. But how continuous data is different than discrete data. Continuous data, you can have partial values, meaning, and the easiest way to describe that is, for this kind of data, you can have, let's say, 0.5 or half. That's the best way to think about this. Whereas for discrete data, it's distinct, it's counted, it's not a measured quantity. For example, the number, I could ask, if you guys were in class face to face, I could ask the number of students that like rice. You raise your hands. I count how many of you raise your hand. That's a number as a value, so it's definitely quantitative. However, you can't have like a half a person like rice. Whereas if we go back up to continuous data, if we're talking about how tall you are, could you have half a centimeter? Could you have half a foot? Could you have half an inch? And the answer is yes. So continuous data, best way is it's a measured value, and you can definitely have parts, so like halves, let's say. Discrete data, still quantitative, but you can't have parts. So cannot have parts. So can't have half a person, can't have half of an animal, let's say. And we're going to do some examples with this. So our first example, we want to state the type of data. So from the ones that we just did, categorical. So I'll just write up here, cat for categorical, and we'll write con for continuous, and we'll write dis for discrete. And remember, these two can have numbers, and continuous can actually have a part. So I'm just going to write like 0.5. So for the first one, the number of mugs of coffee that you drink in a day. So the number of mugs that you drink of coffee in a day. It's definitely got a number for an answer, so we know it's not categorical. And to decide if it's continuous or discrete, you're going to ask yourself, could you have a half of a mug of coffee? And the answer is yes, so this is continuous. I'm just going to write con for short. B, the type of pet at home. Dog, cat, bird, rodent, reptile. Definitely not numbers for answers, so this has to be categorical. The number of pets at home. This has a number for an answer. Can you have half a pet? For being technical, no, you can't have half of a dog or half a cat. So this would be discrete. Number for an answer, but you're just counting how many. And then D, the amount of coffee in milliliters that you drank in a day. It's a number, so we know it's not categorical. So continuous or discrete. And you're going to ask yourself, can you have half a milliliter? The answer is yes. So this is continuous. So now we're going to switch gears. We're going to do histograms versus bar graphs, and these are different. So oftentimes they're thought of as being interchangeable. However, these actually are different. A histogram. So you use a histogram for continuous data. So numbers for answers. And the bars can touch. Well, actually, the bars have to touch. Whereas a bar graph has spaces between the bars. So it has spaces and is used for discrete data. So histogram, continuous, bars touch, bar graph, discrete, has spaces. So our next few examples, we're going to create some bar graphs. So if you have some different colors, you might want to grab them. You don't have to, it just makes it look nicer. So what we have here is called a frequency distribution table. Now normally I would ask this question in class, we would raise our hands, we would do the tallies, and then we have our frequency. Frequency is just the number, so how many liked each team in this case. And then we're going to fill out the percentage column, because often seeing percentages helps us for statistics. So if we pretend I asked everyone what their favorite hockey team is, and I listed the Leafs, the Red Wings, the Blues, the Canadiens, the Blackhawks, and the Rangers, and then I have other, the first thing you're always going to want to do is come up with a total. So take out your calculator. 8 plus 8 plus 3 plus 7 plus 1 plus 0 plus 9. Hopefully you get the same thing as me, 36. And then percentage. How do we find a percentage? So you want to take your frequency, 8, and then you're going to divide, just like you're finding your percentage on a test. So take our frequency, divide by the total, 36, and the maximum percent you can get, 100 times 100. So type that in your calculator. 8 divided by 36 times 100, and we'll go to we'll go to the nearest whole number actually, 22%. Detroit Red Wings, we lucked out, it was also 8, We know the answer to that, 22%. St. Louis Blues. So we're going to do, actually, we'll do one more together so you guys can all see it. Then after that, we don't have to show our work. You guys get the idea. Frequency divided by total, 36, times 100%. Using your calculator. Nearest whole number, 8%. So hopefully you get the idea. Let you guys do the rest on your own. 7 divided by 36 times 100. Nearest whole number, 19%. Next one, 1 divided by 36 times 100. Rounding, that's 3%. 0, that one's easy, that's just 0%. And then 9 divided by 36 times 100, 25%. And now we're still going to calculate the total column because, or space, because that gives us a good self-check if we're right. So what I want to do is add up all of your percentages. 22 plus 22 plus 8 plus 19 plus 3 plus 25. I get 99%. Now, theoretically speaking, that should total 100. However, we did some rounding. So if you had anything between, we'll say 98, which is being generous, to 102, I would say you're probably on the right track. If you get something less than 98 or bigger than 102, I'd go back, double check your work, because there's probably some major mistakes or some really bad rounding going on. Realistically though, you should be pretty close to 100 every time, 99, slightly over 100, just based off rounding. Okay, so make sure you know how to fill out that kind of table, so frequency distribution table. The next thing we are going to do, we are going to create a bar graph. How do we know we're going to create a bar graph? Well, yes, I told you, right there, it says bar graph. But if you look at your data, you have to say it has numbers, right? Is it continuous or discrete? So can half a person like a team? No. So we know that this is discrete. Discrete goes with bar graphs, which means bars don't touch. So our success criteria for a graph, give it a title. I'm going to call it favorite NHL teams. The next thing, label your axis. So your y-axis, it's going to be hard to squeeze this in, but this is always going to be frequency. And then along the x-axis, this is going to be your x column. So this right here. There's our x. So this was our, we'll just call these the teams. I'm going to write them down here. And then from there, it's pretty easy. So I'm going to use some different colors. I'm going to use some short forms. So I'm just going to call this Leafs. And then we're just going to make, you would use a ruler if it was like a test, but freehand is fine for now. Go up to 8. And there's our Leafs. Color that in. Sorry, it's making those weird squiggles again. And remember, bars can't touch. So we'll go skip one here, and we'll just call this the Wings. And they also got 8. Now we color that bar in. Now we'll go to the Blues. Blue's got 3. And then the Canadians, they got 7. I'll just write the halves. Excuse my freehand, it's tough tough writing on this. And then the Blackhawks, so we'll say the Hawks, they got 1. Now, one thing you're going to want to be careful of, this bar graph I have starting at 0, just so we can have a bar if we got nothing. You don't have to have it that way, it doesn't really matter, but just be careful of that. Rangers got 0. Which technically is 1 up on my scale. And then other, let's use purple. So this would be for people that liked any other team than those mentioned. And that one all the way up to 9. So 9. Try that over again. Hopefully we don't end up with any weird things again. And there it is, easily a bar graph. So we have a title, labeled our axes, colored our bars. Now you're also going to be asked to write a statement. You can't go wrong as long as you say something about this graph that makes sense. So you could say stuff like, the Rangers were the least liked team. You could say the most people liked a team other than what was mentioned. You could go above and beyond and say something like 8 plus 8 is 16, plus 9 is 25. You could say 25 out of 36 people like the Leafs, the Wings, or another team. Doesn't really matter. I'm just going to keep it simple here, and I'm going to say the least favorite team was the Rangers. And a good thing to do, like a level 4 response for this, is actually like writing the percentage. So 0%. Again, you can write anything you want as long as it matches the data. And remember, the goal of statistics is to provide data about the population. So to provide statistics, to provide data, so that people can try to make generalizations or try to make conclusions, to gain information about their audience or their population. Our next example, example 3, we're going to create a histogram for the following data, which is displaying the average number of hours watched TV or on social media during the school week. Now, aside from me telling you it's a histogram, you should know, if I don't tell you to make a histogram, that it's a histogram because we're talking about time, and it tells you it's in hours. And you're going to ask yourself, can you have half an hour? And the answer is yes. If the answer is yes, that means you're making a histogram, which means the bars touch. Now in this case, I gave you a table. It looks a little bit different. So it has tallies. So this would be like, again, if you were to ask this question on a survey, or if I was to poll the class and then count the number of hands, you just make those little ticks and then write the frequency. I did not include the percentage tab on this table. Make sure you know how to do it. I'm assuming most of you are going to after seeing it for one example, so I didn't include it here. What we are going to do, though, is we're going to complete our frequencies. So 3 ticks, 4 ticks, 5 plus 3, 8, and then 5, 3, and 2. And then double check that that adds up to 25 to make sure you did your count correctly. So 3 plus 4 is 7, plus 8, 15, plus 5, 20, plus 3 and 2, 25. Perfect. Give it a title. We'll just call it, I'll call it TV/social media. Label your axes. Your y-axis is always frequency. And down below, we'll call this time. Start with black, doesn't matter what color. So this is 0 to 5. And one thing, we should put the units time in hours. So 0 to 5, there was 3, so we'll make a bar up to 3. Our next one was 6 to 10. That was 4. And again, we're making a histogram. Bars can touch. 11 to 15. That was 8. 16 to 20. That was 5. 21 to 25. 3. And then 26 to 30. And that was 2. So you can see with the histogram, it's compacted a lot more than a bar graph. And write a statement. Again, you can say anything that you want, as long as it goes with the data. So this time I will say, 8 students watch TV or were on social media 11 to 15 hours per school week. Again, you can be creative, you can say whatever you want as long as it fits the data. The next type of way you can display data is with a circle graph or a pie chart. Normally we would do this in class. However, I'm assuming most of you don't have protractors at home, and that's okay. So I'm going to go over how to make a pie graph, but you're not actually going to have to do it for a test or an assignment. It's just another visualization. So we have a monthly budget. We're going to create a circle graph. So we're going to go through the steps of creating it. The only thing I might ask you on a test is, or on an assignment, is to complete this table. Which is very similar to the tables that we've already completed. So again, don't worry about it if you don't have a protractor at home. You don't have to worry about it. We'll go over the steps, but you don't got to worry about it. Just complete the table. So we got rent, transportation, food, clothing, entertainment. First thing, add those all up. So 9 plus 4 is 13, plus 5 is 18, plus 1 is 19, plus 2, $2,100. Now, if you were making this by hand, instead of knowing the percentage or caring about knowing the percentage, you want to know the number of degrees in that pie slice. So the first thing you're going to have to remember, and it might be a good idea to make a note if you don't, does anybody know how many degrees are in a circle? If you do, shout it out. I heard a few of you say 360 degrees. Perfect. So we're going to do this very, very similar to how we did percentage. Take your frequency, divide by the total. But instead of multiplying by 100, since we're not doing percentage, we're doing degrees, multiply by 360. Type that in your calculator. 900 divided by 2100 times 360. We'll say go to the nearest whole number, 154 degrees. We'll do it once more together, and then I'm sure I get the idea. 400 divided by 2100 times 360. Rounding, that would be 69 degrees. Do the next ones on your own. Hopefully you got 86 for the next one. 17 for the next one. And if we did our math correctly, 34 for that one. Now, just like we have a self-check for percentage, you want to see if they add up to 100 or close to it. Let's add up our degrees to make sure it's really close to 360. So 154 plus 69 plus 86 plus 17 plus 34. 360, right on, perfect. Again, as long as you're kind of between 358 and 362, that's me being very generous. Really, it should be like 359 or just over 360. So that right there in that table, that's the most I'm going to ask you to do. But I'm going to show you how to do it. So if you did have to do it by hand, you'd make a circle, you'd mark the middle of your circle, you would draw a straight line from that dot in the middle to the edge, and then you would use your protractor, drawing a line every time. The match is 154 degrees, 69 degrees, 86 degrees, and so on. I just did a very simple one. In Excel, you can use technology. If you did do it by hand, this is what it would look like, and then you don't want to make sure that you have a legend or a key. So that's it for making displays. Now we're going to work on getting data from displays. So I've given you a graph. You have to extrapolate the data, pull the data from the graph. In this case, a bar graph, because the bars aren't touching. So favorite sports of students in 5th grade, which sport's most popular? That's the highest bar. That was soccer. What was the least, the lowest bar? Tennis. Does that mean your answer, or does your answer to B mean that students don't like that sport? No, just means that they had the least amount of students that liked it. And again, this is just representative of one small sample of students. Obviously, it doesn't apply to the whole population. How many students chose gymnastics? Since our scale is going up by 5, you kind of got to estimate, let's say 14. How many students participated in the survey? So this is an important question to make sure you know how to do. So you need to add up all those bars. So what I like to do is write the numbers on top, just to be safe. So that's 25. Let's say that's 18. That we just said was 14. We'll say that's 28. And we'll say that's 12. So now that you have the number of students in 5th grade that like each one of those sports, just add them all up. 25 plus 18 plus 14 plus 28 plus 12. So add all those up, we get 97 students. Just double check that, 25 plus 18 plus 14 plus 28 plus 12, 97, perfect. The last example that we're going to do, so we have a histogram, because bars are touching, and we have what their score was, their final percentage on their final exam. So how many people scored between 60 and 80? 60 and 80, that would be that bar, which looks like 40. How many scored at least 80? So at least 80 would be from here over, so the blue bar. Kind of guesstimating here, I don't know, let's say 22. How many students were there? So again, we're going to I like to write the numbers on the bars. We just said that was 22. We said that was 40. That's 20, we'll say. That's 9, and we'll say that's, I don't know, 4. So if we add those all up, 4 plus 9 plus 20 plus 40 plus 22, 95. Now D is a good question. What percent of the class finished with at least 60? So at least 60 would be from here to here. So that's the green bar and the blue bar together. So that would be, we'll do 40 plus 22 first, because that's those two bars. So that's 62. But we want the percent. So remember, to find a percent, take the number, which we got 62, divide by how many, which we just got how many there were in part C, 95. Don't get confused with the pie chart. This is not a circle, so we're not going to multiply by 360 when you're finding a percentage, always by 100. So take out your calculator, 62 divided by 95 times 100. We'll say around at 1 decimal place. 65 when we round 0.3%. Hopefully there's no questions, but again, if you do have any questions, you have many different ways to get in contact with me. Asia, email, post in the homework help forum in the discussion of D2L, or join one of the two Teams meetings I have set up throughout the day, which you can find in the activity feed. And I can answer your questions in real time. So from here, go back to D2L, move on to the next thing, which I believe is work in your workbook. And then there's going to be a survey posted soon, or already has been, depending when I get to it, for you to work on as well.